Okay, as far as the quiz goes, I will go ahead and get that graded before I leave today. In fact, you should see it in the grade book before the end of 7th. Everything works out fine. And then tomorrow we'll go ahead and talk about it as part of our class. So, a couple things. Don't forget that next week, Friday the 13th, that's when your second exam is going to be. Okay, so this material, this current lesson that we're on, polar function graphs, this is the material that's going to be on the exam. So yesterday I went ahead and passed out the note cards. Did anybody need another one, or was anybody not here to collect one? I'm not remembering. Nobody needs a note card? Okay. All right, so we still have just over a week ahead of time, so if you want to come on in for tutorials, ask some questions, definitely go ahead and do so. This paper that you picked up, this is the assignment for this lesson. Pretty much by tomorrow, we're going to have this wrapped up. So this is going to be due on Wednesday. Okay, so we're going to go ahead and start. In fact, with this done, we are completely done with Unit 3, and we're ready to go ahead and move on to Unit 1, which has a lot of material that should be just review for you, a lot of algebra-based concepts. So hopefully that'll be a nice change of pace away from the trig for a little bit. But this will be on Wednesday, and this right here is what really is good practice for that test on Friday. Now, one other thing, this was just told to me earlier this morning. I had no idea, so I'm going to have to change things up a little bit. I posted to the website on Monday. Okay, please make sure to bring your charged Chromebook with you to class, because I think you've already been doing this in your English classes. The students are required to take a pre-assessment before the TSIA. So you've done it in English, we got to do the same thing in math. So it'll probably take us about 15-20 minutes, I'm guessing. Does that sound about right? Okay. So what we're going to need to do, I've already uploaded this little PDF here that's going to walk us through. We're going to go ahead and do this together. So if you don't have an account, I'm going to help you sign up for one. We're going to get that all situated. And then on Monday, when you get your certificate, I'm going to have a folder or an assignment, something along those lines, created on Google Classroom, where you'll go ahead and upload your certificate to me. Because I need to apparently keep track of those going into the exam in case anybody comes back and asks for that. I have to be able to provide it. So on Monday, please bring your charged Chromebook. Okay, other than that, are there any questions about anything coming up? Okay, well, let's go ahead and finish up our polar coordinates lessons. Okay, we are on example 5. It says a portion of the graph, of course that should be graph, okay, a little typo, of the polar function r equals f of theta, where f of theta equals 3 cosine of 3 theta, is shown in the polar coordinate system for a less than or equal to theta, which is less than or equal to b. So this problem is actually very similar to number 4 that we solved on Tuesday. What we're saying is we have this graph of 3 cosine of 3 theta, which hopefully you'll recognize as a rose. Okay. If I were able to see the entire graph, okay, I'm then going to come back. One of these intervals on the 4 answers, I'm going to use to restrict the graph. Okay. This is all I'm going to have left is the portion in quadrant 1. We want to find that interval that's only going to leave me with this small part of the graph. Okay. Now, several ways we could go ahead and do this. In fact, we're going to go ahead and solve this in the beginning the same way we did number 4 on Tuesday, and then I'm going to go ahead and show you an alternate way. All right. So let's go ahead and start with A. Let's say that we believe the interval is between pi and 3 pi over 2. So we're going to test the values in each of my answers. Now, here's one critical piece about these types of problems. When you're testing these intervals, okay, one value has to correspond to one endpoint, while the other value has to correspond to the other endpoint. Each value should give you its own endpoint. If it doesn't do that, we got to mark it out. Okay. Well, let's go ahead and plug it in. Okay, so first up is pi. So I got 3 cosine. 3 times pi would be 3 pi. Okay, so now we need to go ahead and evaluate that. So if I start here, there's 1 pi, there's 2 pi, there's 3 pi. So it is a quadrantal. Can anybody tell me what cosine of 3 pi is? It's -1. Yeah, remember quadrantal, we have this coordinate here, -1, 0, and we're looking for the x. So this is going to be 3 times -1, so I got -3. So that means I get a radius of -3 at pi radians. Okay, well, let's take a look up here. If I rotate around to pi, remember the negative pushes it in the opposite direction, so that does give me one of the endpoints of the graph. Okay, so far things are looking good. Okay, now I'm going to do the same thing for 3 pi over 2. Okay, so let's see here. This is going to be 3 times the cosine. What's a 3 times 3 pi over 2? 9 pi over 2. Okay. So in order to evaluate this, we got to know where 9 pi over 2 is. Addie, what would that be as a mixed number? 9 halves. I'm sorry? Not sure? Okay. William, what would that be? 8 1/2? Ooh. 4 1/2. There we go. So this would be 4 1/2 pi. Well, let's see here. There's 1, 2, 3, 4, and 1/2 pi. So this one's going to end up being a quadrantal as well. Okay. So what's the cosine of 9/2 pi? 0. So this is going to be 3 times 0. So I got a radius of 0 at 3 pi over 2. There we go. So I'm going to come on over here to my polar grid. Well, here is 3 pi over 2 with a radius of 0. It's the pole. So the A is already looking pretty good. Each value gave me its own endpoint. Okay. Now, here's the thing. Just because that happened, it doesn't automatically mean that's my answer. I don't have to look at the rest of them. Remember on number 4, we had 2 answers that did the same thing. Okay. In fact, if you go ahead and do the same thing for B, if I plug in 0 and pi over 2, each one is going to go ahead and give me the endpoints. In fact, you can double check me on this, but I'll go ahead and tell you that if you plug in 0, you get a radius of 3. And if I plug in pi over 2, I get a radius of 0. Okay. So you can double check those points. So see, here's the thing. I've now got 2 answers where both values are working. So what did I do on Tuesday? How did I kind of decide between them? Or at least come up with a way to eliminate one? Okay. What's that, Marina? What do you mean about the quadrants? Okay. So like in this one, we're going between pi and 3 pi over 2. So we're looking at this bottom left quadrant right here. So if we really believe that this is the interval I'm going to apply to this equation, well, why don't I go ahead and choose an angle on this interval? Okay. Because if that's truly the answer, then shouldn't it be giving me a point in quadrant 1 on that graph? Okay. So let's choose something easy. Halfway between pi and 3 pi over 2, let's say 5 pi over 4. Okay. So I'm going to go ahead and take 5 pi over 4. Let's see if this works. Okay, let's plug it in. Let's see what happens. Okay. So let's see here. So I've got 3 times the cosine, but what's 3 times 5 pi over 4? How many fourths would I have? 15 pi. Okay. There we go. So first I got to figure out where that 15/4 pi is going to be. So as a mixed number, that would be 3 3/4 pi. Is everybody okay with that? So let's see, here's 1 pi, 2 pi, 3 pi. Now I only want to rotate an additional 3/4, which is going to put me in quadrant 4. Okay. So I know I'm in quadrant 4. And because I rotated 3/4, is everybody okay that that's a 4? Is everybody okay that my reference angle would be pi over 4? Okay. Well, we got my angle. Remember, we're going to use this to create a right triangle. The hypotenuse is 1. Remember, what's nice about this, it's the isosceles special right triangle. Audrey, what are those 2 lengths? root 2 over 2. So this is root 2 over 2. This will be negative root 2 over 2. So if I plug this in here, I'm going to end up with 3. Cosine of this angle is root 2 over 2. So this is what I'm getting for the radius. Okay, we're testing a value inside the interval of A. Is everybody with me? Okay, so here's the point that I got. Radius of 3 root 2 over 2, and we got that at 5 pi over 4. So let's use this over here on our grid. What quadrant would this be in? Okay, what do we think? 1, 2, 3, or 4? Okay, it'd be in 3. See, here's the thing. This is one of those problems where we're going to have to solve it with no calculator. So I'm looking at this fraction. I have no idea what its decimal value is, but that's okay. I know that it's positive. So when I rotate around to 5 pi over 4, from the pole, I would have to move towards that angle. So it's got to be somewhere along that line right there, whatever value it has. Okay. Well, the problem here, there's no part of the graph in quadrant 3. Our graph is in quadrant 1. So what do you think that tells me about A? A is out. Okay. Answer cannot be A. Okay. Now we could continue to go ahead and work the problem like this. We could go ahead, plug in 0 and pi over 3, 0 and pi over 6, see which ones work. If another one happens to have both values work, we'll choose another angle and plug in. Okay. Now you could absolutely continue that way, find your answer, you're good to go. Now, let me show you another way to do this. Okay. Now, you couldn't do this on number 4 because it only had theta, but I'm allowed to do it on this number 5 because we have a horizontal dilation. There's a manipulation of your variable. Okay. Now, because my graph is in only one quadrant, this means that the radius can only have one sign. It has to be positive or it has to be negative. It can't be both at the same time. Okay, so knowing this, let's revisit A. Let's see why A wouldn't work. So I'm going to say this is the interval. It's between pi and 3 pi over 2. Remember, we're saying this is the A and B that we have here. But see, the thing is, we have theta, but what's in my equation? It's 3 theta. I want to see what the interval would be if I rewrote that to have 3 theta. So all I'm going to do is multiply through by 3 to make that happen. So 3 times pi is less than or equal to 3 theta, which is less than or equal to 9 pi over 2. So here's what we got. This is telling me that we're looking at an interval from 3 pi all the way to 9 pi over 2. Okay. So this is covering 3 quadrants. Now, you remember what I said about the radius? It can only have what? One what? Sign. It can only have one sign. Okay. Would that be, is that what would happen if I would rotate through multiple quadrants? I mean, think about it. We're dealing with cosine, right? What's cosine in quadrant 3? What's cosine in quadrant 4? The sign is changing. That can't happen. So that's another way to eliminate A. Okay. Let's take a look at B. Okay. Let's do the exact same thing. Let's say that B is the answer. So I believe the interval is going to be between 0 and pi over 2. Okay. Well, again, we have theta, but we want 3 theta. So I'm going to multiply through. So this is going to give me 0 is less than or equal to 3 theta, which is less than or equal to 3 pi over 2. So this time we have 0 to 3 pi over 2. So we're going across these 3 quadrants. Okay. So what do you think? Is this going to work? Remember, the radius can only have one sign. Okay, you're shaking your head no. Yeah, because what's cosine in the first quadrant? Positive. What's it in the second? Negative. The sign is changing. You can't do that. Now remember, there is another way. Graphically, if I were to go ahead and sketch 3 cosine of 3 theta, you'll notice I've already got it here. Okay, well, let's take a look. You remember I said that any part of the curve below the horizontal, that's where the radius is negative. What about any part above? That's where the radius is what? Positive. Okay, so let's use this one here. We're going between 0 and pi over 2. Okay, well, here's 0. Here's pi over 2. So you'll notice I'm going from a positive to a negative. So there's another way to see that. Okay. All right. So I've already eliminated 2 answers. What do you think? C or D? William, you think D? Okay, let's try it. Let's go ahead and use this method where I set up the interval. Okay. So between 0 and pi over 6. Okay, again, we have theta. We want 3 theta. So I'm going to multiply through. 0 is less than or equal to 3 theta, less than or equal to, what's a 3 times pi over 6? Okay, pi halves. So we're going between 0 and pi over 2. How many quadrants is that? 1, and we're going to keep the same sign in that quadrant. You're absolutely right. And if you were to go ahead and check C, yeah, you're going to see that it doesn't work. Okay. I mean, shoot, I'll just go ahead and use the graph here to kind of help us out. See, this is going between 0 and pi over 3. Okay. So here is 0. Here's pi over 3. So again, yeah, it's changing from positive to negative. You can't do that. Okay. How are we doing? Does this make sense? Remember, even if what I was just talking about with these inequalities here, if that confuses you, remember, you can still just go back and plug in like we were doing a few moments ago. You're still going to be all right. Okay. Now, here's how we're going to end things. Okay. You've got one problem left, and then these notes are done. So I want you to think about what we've talked about, all week, all these ideas, these examples. Between now and tomorrow, try number 6. Okay, see if you can find the right answer. We'll go ahead and talk about it tomorrow after we discuss, any questions on the quiz. Okay. All right, how are we doing? Okay, well, that is it. That's all we got. And don't forget, what are we going to bring on Monday? Please bring your charged Chromebook. Yes. Okay, let me go ahead and get this set up. That is not what I need. This is what I need.